first one, there in chapter 3, the metals part, I believe we haven't done some of them. So I'm going to finish up this. So please take out this metal reaction with metal notes. Especially, we haven't done the last parts, the review exercises, I believe. So what I'm going to do is I'll finish up this review exercise. Yeah, chapter 3 review, this one. Okay. And then the second one is to please take out this notes metal, chapter 3 metal notes. And then today we are going to do additional worksheets on the metal. So that next week. I may not be doing tests on this chapter, but I'll do together after we finish ionic equations. Okay, so right. So let's start since the time is already 6:30. Okay. I'm going to start with this metal chapter 3 metal notes first. Yeah, please come in. Yes, please come in. Okay, as I mentioned, I'm going to go through this chapter 3 review from here. This is where we haven't actually finished doing this. More or less, we have done going through the theory practically. Is that right? Okay. So chapter 3, which of the following is not a common property of it? Sorry, it's on page 14. Yeah. Which of the following is not a common property of metal? Generally, I think it's going to be a low melting point, right? So this is low melting point is not a common property. Which of the following describe the force that hold together a metallic lattice, which is the electrostatic attraction between cation and delocalized electrons? So it will be D, right? Good conductor of electricity because they have a freely moving electrons. They have a freely moving electrons. We make it slope, like I don't know why. And then the general rule for reactivity of the metal. What do you think for this question, Paul? Is it increase going down the group or decrease going down the group? Forgot everything. I don't this part. Okay, if maybe metal is group 1 or 2, right? So if you recall from chapter 1, group 1 and 2, as you go down the group, like potassium and sodium, which one is more reactive? Which one is easier? Potassium is more reactive, right? So it's like as you go down the group, reactivity increases. So it should be A. Then the next one, Which of the following is not a step associated with refining of metal? We are trying to do a refining, like trying to make it pure. Distillation, reacting with chemical, washing with chemical, extracting of metal from the ground. Refining of metal generally require chemical process. So which one is not a chemical process? Just the extracting of metal from the ground. Refining normally require a certain process. Distillation is possible when you're trying to remove a liquid component. So distillation is a kind of a process that could be used in refining, making it more pure. Like reacting with chemical, washing with chemical. That means extraction of the metal from the ground doesn't make them to be a refined metal. So D is the one that is not a step involved. What about 6? Yeah, copper is able to manufacture into long thin wire. What is it called? Is it ductility or yeah, it's high ductility. Ductility is able to draw into a thin wire. Okay. So then today all of you will be this because Erin not here yet, back yet. Timothy will be. I'm not sure whether is it boy coming out. Okay, anyway, it's recorded, so it should be okay. It's from the metal chapter 3 notes. The last part, review questions, which we haven't done. Which of the following is not a negative environmental impact of mining? Not a negative environmental impact. Increase air pollution, water pollution, increase biodiversity. But biodiversity is not a negative environment, right? Negative environmental impact. That one is this one, because when you do mining, you will do for deforestation. Deforestation will reduce the biodiversity. So that means the process that is not going to happen is increasing the biodiversity. Magnesium and calcium are added to separate test tube with the sulfuric acid. One way to tell which metal is most reactive would be to measure which one? How do you actually do that? Yeah, volume of the gas produced over time. So over time, actually, this what is slightly when they say over time, it should be within the same time. What they are trying to say is it's within the same period of time, the same period. Within the same period, we look at which one produce more. If the metal, a certain metal produce more, which means that it is more reactive. What about 9? Circular economy, but not in the linear economy is which one is not in the linear economy? Only in the circular economy. Yeah, it's for the recycling, right? If a metal reacts with water, the gas most likely to produce is no water. It produces react with water. Any metal that react with water, the gas that most likely to produce is hydrogen. Yes, hydrogen. So they ask you to draw the diagram of metallic lattice of aluminum. So when you try to draw aluminum, probably you don't need to draw so many circles. So maybe just draw like cat iron. I'll just draw like 4 circles here. And then you will have maybe 3 rows. I'm not going to so many. So you need to draw 4 circles, 3 rows. Make sure that they are aligned properly, columns and row. And each of them is representing aluminum cation. Aluminum cation is Al 3 plus. So that means you have to just write down like 3 plus here. So all of them will be just plus 3. Just write down the charges. And as far as possible, of course, they won't be counting very particularly. If you look at like this, how many electrons will be moving around? Because we have a 4 by 3 is 12, 12 times 3 is 36. So there will be quite each at the vicinity of each of them, you should have about 3 electrons here. Okay, this 3 electrons should be randomly located. Maybe just randomly isolated. But you have to put that this is a delocalized solution. Label it. And we can say this is a positively charged, or maybe Al3 plus. You can just write down Al3 plus ion. So the 4 marks generally will be looking at the rows and columns. So lattice structure should have a proper rows and columns. So rows and column will be 1 mark. So it's like having rows and columns. Then having this 3 is going to be a 1 mark. This is 1 mark. Okay. Then the abundance of electrons is normally 1 mark. Electrons is 1 mark. And then the label, the correct label is. This is what we are looking for us to be able to give you the mark. Okay, so that's about the lattice structure. So I have given you an example of lattice structure of aluminum. So if I ask you to draw lattice structure of sodium, you should be able to draw. Potassium, you should be able to draw. Calcium, you should be able to draw. All right. So calcium will be 2 plus because it's in group 2. Okay, describe an appropriate experiment that could be conducted to determine the relative reactivity of lithium, beryllium, deuterium with water in your response refer to the variable that are controlled, change, and measure. So in terms of the variable, this is something that you have to do. They say refer to variable that are controlled. Control mean, what is mean by control variable? Yeah, throughout the experiment, there's something that does not change, do not change. And change, the one that is changed is normally you have a control over it. Okay, so that means this is normally the one that you change is called independent variable. And the one that you measure is dependent variable. Okay, so we have a 3 types of variable for any experiment. You have your control variable, independent variable, and dependent variable. Okay. Independent variable means the one that you determine. Okay, I want this much of volume. I want this much of this much of this. You have a control over it. And normally your independent variable is when you try to vary your independent variable, we'll try to vary in consistent way. Okay, if I'm going to use like 5 centimeter cube, then the next one is going to be 10 centimeter cube. Then it's going to be 15, 20, 25. So what you have to do is the gap between those the changes, the variation that you have on your independent variable should be consistent. Okay, this one we'll emphasize again later on when we do experimental techniques. Okay. So what you need to do is use the same. Generally, what we do is they are going to conduct relative reactivity. So probably what we'll use is we'll use the same volume of water. Use the same volume of water um, in three identical tubes. So it tells you that you are going to use same amount of water in a three identical test tube. Then use same mass of metal or three different metals. Use same mass of these three metals, lithium, beryllium, and deuterium, of three metals in the same form. For example, like if they are the particle size should be the same in the same form and size. So this same form and size as well as the same mass, they are control variable. Okay, so they are generally control variable. These are your control. Same volume of water is control. Same mass of metals and then same form and size. These are control. But having different metals is your independent variable. And then afterwards, we will be then what else do we need to do? Same volume of water, different metal. Then we are going to measure the time taken to completely dissolve in the water. Okay, so generally this is the measure that you do. They say this is what you're going to measure. So you need to mention that you're going to measure the time taken to completely dissolve in that given water. Right? I need to copy them. These are the steps describing of your experiment. So conclusion, when you describe an experiment, then how can you refer to this, what we call it, relative, how are you going to determine the relative reactivity? So you can determine relative reactivity can be determined based on time taken. So if it is a shorter time, that means it's a faster reactivity. So generally, for you to get 5 marks, these are the points that you need to include. You need to include the dependent variable, independent variable, measure, and then how you're going to determine, how you're going to measure. I mean, what are the factors that you're going to involve in your consideration? All right? Any question? Okay, question 13. Scientist has a symbol of 4 unidentified substances. Label them as X1, X2, X3, X4. And as a first step in identifying these samples, she determines some properties of each. She performed 5 tests on each of the samples. The results are presented below. So which means, so the next page. Okay. Ductility, melting point, electrical conductivity, heat conductivity, and malleability. Which substance would be the best choice to be used in electrical wire and why? So it must be a X4. We have our first steps for it to be electrical wire. What are the properties that we have to look at? Conductivity and ductility, because for wire you need to pull into a string. So we have to look at this and this, right? So it needs to be high. This is high, this is high. But here this is moderate, this is high. So I will recommend X4. Since both high electrical conductivity and high ductility wire or are required least likely to be a metal. To be a metal. Which one is least likely to be a metal? X2, right? Because it's like low ductility, low melting point, low conductivity. The only thing is a malleability is high. Is it heat conductivity is moderate. So it's likely that it could be a clay or like something like that. X2. Those we can say something like yeah. So low ductility. Low electrical. So you need to give these two reasons and 3 marks. Okay, don't. Next one. Substance X3 is being considered for the production of saucepan. What two property of X3 would make it suitable for this application? So in X3, what do we have for it to be a saucepan? Heat conductivity is high and malleability is high. Okay, because you need to have this one because saucepan you need to make it into a different shape. Make it flatten it. Okay, not pulling it to a string. You have to be able to flatten it into different shapes. So that requires to have something like this. So it's to have high ability and high conductivity. Okay, last one. What extra piece of information would you want to know about the substance X3 before decide to start using to make the saucepan? There is a one point that we have to look at any saucepan. Okay, as for the saucepan, what is the requirement? We know that it's need to be this and this, right? But out of these three, which one that you need to melting point? Yes. Because if you have a, they say moderate is how moderate. Is it like when you try to like boil water, then you start to melt, then it's not, that's not possible, okay? So in this case, we need to know the exact melting point of it, okay? And then to make sure that that moderate is high enough. So additional information that you need to know is the exact melting point of the metal. Right. Okay, question 14 is about aluminium production. Bauxite is an ore that is rich in aluminium, and the new bauxite deposit has been discovered in Queensland, just 10 meters below the surface. Wow, nice. Outline the steps that you would be necessary to go from the discovery to the production of aluminium soft drink cans. You should use a skill in chapter 3 to assess which aspect of your response are. Okay, so linear economy and circular economy. Currently, it's just from the mining all the way to manufacturing. So in terms of process, when you see the from this discovery to the production of aluminium drink. So after you have a discovery, what is the next step that you do? You need to do what we call it mining. So, okay. So next step will be a mining. So this bauxite will be extracted. It is extracted from the ground. Sent to the factory, right? Maybe sent to the refinery. But there is something called just 10 meter below the surface from the ground, maybe using open cut line. Okay, so you need to also mention about the method that we are going to use. Then afterwards, it will be sent to the refinery. So will be refining. Next step is refining. So they will use like the refining process to remove the impurity. Sorry. Then the last one is manufacturing. So pure aluminum sheet. Will be shaped. Will be shaped. Into soft drink. Those three steps. Mining, refining, manufacturing. Okay, so in terms of define circular economy, circular economy is generally a recycling. Recycling is the main feature of circular economy. Is it? Okay, so generally what we can do is it's where you are going to intentionally recycling. So maybe we can use more specific word. Intentionally recycle. Intentionally recycle to minimize the waste. Waste. And to maybe reduce the maximize the usage of extracted resources. So this is general term. They should actually give you like 2 marks because it's one thing is to minimize the waste and maximize the usage of it. So that will be, and then you are intentionally recycling it. So these are your keywords in circular economy. Then the next step that should occur here to ensure circular model is applied with the so send to the recycling station. Send to recycling station. Put it into the recycling dustbin online container. Explain to environmental benefit of a circular economy model. When you do circular economy, what are the benefits that we can see? There are altogether 4 of them, right? So one of it is reduce the pollution from mining. Reduce air and water pollution. Mining. Nice one. Okay, can you contribute the other 3? Someone contribute the second point. So if you don't need to do mining, it will reduce the air and water pollution. What are the things that it can reduce? Yeah, it's reduce deforestation. Due to mining. What else? Reduce the energy usage. Maybe they may also need to use more energy. Okay, reduce the destruction of because deforestation will leads to destruction of habitats. Reduce the destruction of habitats. And also reduce What else? Or maybe preserve biodiversity. Generally, the last 3 points are linked, slightly linked, but of course, these are also the outcome. You can use the first one definitely must include. For all of the other two, then you can choose. Okay, you can choose one. All right. All right, so that is for the metals. So generally, we are more or less done with metals, but I'm going to use another worksheets to revise all this chapter before we move on to the next chapter. So we'll only move to the next week on the ionic equation because this week seems like not many of them are turning up. Okay, let me this this. We are going to look at this. Probably we'll do the multiple choice question. The multiple choice questions are at the back. It's a little bit it's took it from scan image. No time to read, so it's a little bit slow, but you can still read it. Okay. So I need to go over to multiple choice questions. Can you start doing that one? There are 15 questions. Maybe I'll give you about 15 minutes for you to do. Yeah, yeah, please do this multiple choice questions first. Yeah, by the way, last week I have given you one chapter one worksheet, right? Multiple choice questions. Have you done? You didn't bring? Oh. Okay, then please bring back next week, okay? That chapter one, we're going to check the answer. These are also multiple choice questions from question 1 to 24. We have done covalent substances. Okay, so I'll give you about roughly about 15 minutes for you to do. There are 16 questions altogether. Yes. The what? Tensile strength. Tensile strength is how strong that you can pull before breaking. Okay, are you done? We ready to check the answer? Okay, 3 more minutes. I'm going to go through the question answers for this. Okay, shall we start? All right. So let's look at this question 50. What's the answer? We are trying to find an element that will be liquid at the room temperature. What is the room temperature? What's the room temperature? What's the room temperature? Don't know what's the room temperature. Maybe around 20, 25. Okay. So normally for the room temperature, we define that it is what we call it standard laboratory condition is 27 degrees Celsius. Okay, so this is the standard laboratory condition. Sometimes they call it SC. So under the standard laboratory condition is 27 degrees Celsius. So we try to find for it to be a liquid, it must be between melting point and boiling point. So 27 is here and 27 is here. So which means this and this are likely to be liquid. So 2 and 6, which is 2. Right? Make sense? This is how you identify where is it going to be. Right? The next question is actually accidentally going. The element with the greatest tensile strength is likely to be. Greatest tensile strength means it's expands least when you apply most. And which one do you think it's likely to be? 1, 3, 4, and 5. It's normally nothing to do with electrical conductivity, thermal conductivity, and probably density should be strong enough. The tensile strength is depending on its melting point and boiling point, because when you have a high melting point and boiling point, it's likely to have a high tensile strength. So it will be, I think it should be wood. Okay, question 52. Answer? We have done something like this before. What's the answer for the 52? D. Okay. 53. 53. Most chemically reactive metal occur in group 1 and 2 of the periodic table. The reactivity of these metals is similar questions. Is it increased down the group, decreased down the group? Should be increased down the group, right? Just now it's similar to the questions that we just did. Okay, the following information refer from question 54 to 57. 54 to 57. Let's look at this. The 4 statements about structures are given. In metal, particles are strongly attracted to one another. Tightly packed charged particles are free to move charge. Attractive forces between particles are able to adjust when the particles are moved. So they can adjust. That means slightly variable. Which one of the statement above is best to be able to explain why metals are malleable and ductile? Which one? 1, 2, 3, 4. Malleable and ductile mean the particles are able to move their location, right? They are able to move, slide over each other, try to change their locations. So which means in metal, attractive forces between are able to adjust when they move, right? So in this case, it will be 4. This particular one gives you the malleability and ductility. Good conductor of electricity is 3. How about the next one, 56? Hi, Howard. Hello, Howard. Howard, how are you? Are you good? Okay. 56. What's the answer for 56? Nathan? B. High melting point and boiling point. High melting point and boiling point. It should be A, right? Because it's strong force of attraction that require larger amount of energy. So the high density is due to tightly packed, so which is B. Okay. So when they packed, their volume is small to make the density to be higher. However, do you need to go and wash your face? You're good? Okay. 58. Reactivity of a metal is often related to a historical period of its discovery. Metal with low reactivity are most likely to have been known earliest time or later time. Earliest time. Yeah. Why is the earliest time? What? Because it is what? More common. It's easily be seen because when you know them like earlier, it's generally because of you see them as a pure substances, right? Because it's a we do not have like those like what we call it reactions. We do not know anything about reactions yet, but if we find those elements as pure form, then we can identify those metal as in. For example, like what do you think is the most common metal that they found first? What is the first metal that they found first? It's actually copper. Okay, copper is the one that they actually found first in the earliest in historical because copper is not so reactive, so it could be found like more or less in pure form. Then they found things like a little bit rare metal like silver and gold. Then afterwards we have irons and tin. Okay, 59. A slow reaction with dilute hydrochloric acid does not react with cold water, but will react with steam and undergo rapidly reaction with oxygen. The metal is most likely to be. Okay, it can react with steam. So it cannot be this too, right? So sometimes if you're not very sure what you try to eliminate the choices. Cannot be B or C. So could it be calcium and zinc? They say it's a slow reaction with a dilute hydrochloric acid and does not react with cold water, but it will react with this rapid reaction with oxygen. So could it be A or D? Which one? Because of this slow reaction with dilute hydrochloric acid, it must be D because calcium will react not so slow. It will still react with this. All right, 60. Answer for 60. Small piece of metal, calcium, iron, magnesium, and zinc are added to separate test tubes containing this. Expected order of reactivity. So obviously, you know which one is the most reactive. Calcium, followed by magnesium, then zinc and iron. So it should be B. Decreasing reactivity. What's the answer for 61? Which one? You don't need periodic table, right? I think I mentioned about the order of metal reactivity series. Definitely sodium should be more reactive than magnesium and iron, copper. I think it's A because they say decreasing reactivity. Which of the following pairs of reactants is least likely to react spontaneously when mixed? So that means they do not react easily. Magnesium and water when heated, tin and dilute hydrochloric acid, mercury and dilute hydrochloric acid, sodium and oxygen. Which one? Sodium, oxygen definitely very fast, so it cannot be this. Magnesium and water when it is heated, it will react. So this cannot be true. So it's either A or C. Can tin react with dilute? So you are reacting with both dilute hydrochloric acid and tin and mercury. Which one is less reactive? Yes, mercury is below copper, right? So mercury is below copper. That means mercury is less reactive. This one is less reactive. So which means answer should be C. Of the metals given below, which one is likely to be the most difficult to extract from its ore? Yeah, it's sodium. Because the most reactive metal is the most difficult to be extracted because it's bond. It's something like you have to use electrolysis. 64. Never found in an uncombined element. So that means found never found as an element on Earth. So should it be reactive or not reactive? It should be reactive. So which one is the most reactive one? Magnesium, right? So could not be found in elemental form. 60 metals are used by human society. By contrast, 2000 only 7 metals are used. These metals are copper, gold, iron, lead, mercury, silver, and tin. Best explanation for the use of metal being limited to these metals is that they are C, right? They can be easily extracted because they do not have like the advanced technique for you to be able to extract. So those least reactive metals are normally found, are used more commonly. Okay, now let's go back to this structure question. Question 18. I'll give you 5 minutes or maybe 2 minutes for you to try this. Atomic number 90, solid at the room temperature, easily cut with a knife. Chromium, which has an atomic number 24, solid at the room temperature, but it's a hard substance. So you know how to do electronic configurations? Bonding expected in potassium and chromium. Two more properties that the potassium and chromium have in common. Both are metals, so you should be picking like the metal properties. I want to generally emphasize the comparison of chromium, which is a hard substance compared to the potassium. This is a very important analysis that we need to it's kind of like a reasoning that we need to focus, okay, in this particular question. Other than that, the rest is pretty recall type of questions. The only thing that I want to focus is this, the second part, describe the bonding expected in potassium and chromium, and also why chromium is harder than potassium. So in order for us to be able to answer that, we are going to look at their electronic structure. So let's look at the potassium electronic structure. So potassium, can you write down the potassium electronic structure? It's a 1s2, 2s2, 2p6, 3s2. This is 10, 3p6. Then you will have a 4s1. So this is the valence electrons. So that means it will form one electron will be able to lose. So in the sea of electrons, this is what we have. The next one is a chromium. Chromium is 1s2, 2s2, 2p6, 3s2, 3p6. Then you have a 4s2. This is 22. Wait, 10, 20. So we have four more. Then we have a 3D. What do you have it? 3D5. And sorry, it should be the 4s1 and 3D5. Then your outermost shell is in 4s and 3D. So you can have about 6 electrons which can normally lose. With 3D and 4s. Both of them has a 4s, but the thing is that this is 8. Yeah. Okay. So if we look at this, in terms of nuclear charge, chromium has a larger nuclear charge. And smaller atomic radius, smaller atomic size. So able to form positive ions with larger charge. Than potassium. Because potassium can form only 1 plus, but chromium is 3 plus. Okay, it can form 3 plus and 6 plus. Then potassium in produce more freely moving electron. So in this case, we can see that chromium has stronger metallic bond. This comparison of metallic bond is very important. Okay, so this part is a typical questions that they can ask. I mean, A and C you should be able to answer because it's kind of recall question. But you need to do a bit of an analysis here for you to be able to answer B. Yeah. But actually, so the B is here. This is A. This is B. Okay, then you should be able to answer B well. So chromium has a stronger metallic bond. So it is characterized by the harder metal. So those comparing of harder metal and softer metal, you have to look at 3 main points. The first point is the atomic size. So smaller atomic size, larger nuclear charge, and then produce more freely moving electrons. Okay, so they will actually create a stronger force between them. It will create a stronger metallic bond. So when you have a stronger metallic bond, it will be a harder, it will have a higher melting point, boiling point, it will have a higher density. Is that clear? Nathan? Seems confused. Reading. Oh, reading, still reading. This is positive ions with larger charge. Because this will produce either Cr3 plus or Cr6 plus. This one can do only K plus. Okay. So able to form so okay, right, maybe I do not use so, maybe this is 1 point. It's 1 point. Able to form positive ion with larger charge than K. So this is 1 point. And produce more freely moving electrons. So that is, so 3 points. Due to a larger nuclear charge and atomic size, that is 1 point. It's point number 1. Then larger to form positive ion with larger charge. So this is point 2. Because of you have a higher number of valence electron, then it will be have a more freely moving electrons. So this is point number 3. So based on these 3 points, chromium will form a stronger metallic bond. Make sense? How do you find out the picture? Because chromium has a here 24. This one has 19. So if you're talking about core charge for this is 18, right? This is for 18. This is going to be 23 here. Because you have this guy sits on the outermost shell in terms of the core charge. So you can say that it is a larger nuclear charge, definitely. Two properties of common is like electrical conductivity and then heat conductivity. And they are luster and then malleability and ductility. This is something that you can mention. But you can't compare high melting point and boiling point because and then high density because potassium is not a high density. So when you look at C, you have to use other properties, not this property that relevant to this. Is that okay? 18, any question? I'll let you copy first. All right. Can you move up? The next question is not that difficult. I hope this one is major though. Luminaire is not suitable structural metal to be used when building a bridge. Why is it so? So it is not sufficiently formed because it's a malleable metal. Structurally malleable, no, not strong enough. So in terms of this, it's not strong, insufficiently strong and rigid. Silver is not used to make so-called silver coins such as 20-cent pieces. Because it's of course silver is not used because of the cost. Actually, high cost. Actually, when they say silver coin, that's for your knowledge. The silver coin that we have is not really made out of silver coins. Actually, it's an alloy of copper and nickel. Copper and nickel. It gives you the appearance of silver, but it's not made of silver. Recycling luminaire is more economical than producing it from the bauxite because it uses less energy. For part C, recycling uses less energy. Then refining from its ore. Okay, they say after iron age battle, it was difficult to maintain an iron sword in a shiny, sharp condition. Because it's a pure iron, will corrode easily, right? When it exposed to air and water. Artificial joints of the human bodies are constructed from titanium. So it is light and strong. And do not corrode easily. So these are the properties that is useful for, because it needs to be able to stand for a long time. We move on to question 2. Question 1B, sorry. They say use a diagram to show the structure of typical metal at the atomic level, which is the same as just now. So I'm not going to do this A. You can do it. So it's a typical metal. That means you can use any charge. It's not necessarily it's 3+. Maybe just use a charge. Then by using the structure from part A, explain the following properties. So A, I presume that you are able to do. Just now we used aluminum to demonstrate that one, right? So how do we answer B part 1, 2, and 3? Due to electrical conductivity is due to the what we call it what do we have? Delocalized electron, right? Due to the mobility of delocalized when a potential difference. Actually, you don't really need, but potential difference is applied. Because normally for the conductivity, you need to have like a potential difference for the charge to move. So we still put this. Malleability and ductility. So those ions and electrons are able to move. Metal ions and electrons relative to each other. Relative to each other. So that means when they are able to move, so they are able to layers of positive ion can slide over each other. So these are generally the point. Without breaking the attractive forces between them. Okay, part 3 is just the metallic bonding, which is the attractive force. So force of attraction between positive ions and C of the localized solution. For the reactions, probably I will let you try at home. This one, you should be able to do that. Okay, let's go back and refer to the equations that we have done. Maybe I give you a rough idea. They say the object in the desert is a deeper part of the ocean. This one have no oxygen. This one has no water. Luminaire we have at Farid because they use a building material window frame because it's a aluminum oxide form protective layer. That means it will not form like it will not have other further reaction. Sodium react rapidly with oxygen but store in water rather than a deoxygenated water. Because it can also react with water or does not react with water. But react with water. Okay, so that's why. And then gold does not react with water or atmospheric gas, but it's often alloyed with other metal because it's to make it stronger. Because pure gold is very soft. So you can use those particular reasons to do this. Alloy. Please go back. Yeah, I know. I'm looking at which one. Okay, I think we don't have the rest. I think we'll have to use the go through next week. So please try to do the rest as your homeworks and then bring it back. Next week I'll go through the remaining questions. Then we'll start chapter 4, which is the ionic compound. With H2O, yeah. And normally, when you make the alloy, normally it will make it harder. So normally when you make it into an alloy, it will also make its melting point to be lower. So it's easier for it to be like make it softer. So when you look at like normal gold, it is soft, but when you mix with something else, it will make its melting point to be lower, so it's easier to handle. In the meantime, when it's become in a normal temperature, it's become harder than the normal metal, and then it's also more durable. So that is a benefit of the alloy. So which we are going to look at in the other question as well. So okay, so let's try the rest of the question as your homework. So and then please bring back this. I'll finish up the rest of the questions. Yeah, then we'll start chapter 4 next week. All right, so thank you very much. All right.